Hello, everyone. How's everyone doing? I hope better than me, and I hope you've gotten over your New Year's hangover by now. Uh, I sure did. First thing I want to say is if you can't hear me well, if you can't see me well, video is out of whack or sound is out of whack, please put a note in the comments section immediately so that I can reset. Okay, last time I spent the last 6 minutes of the video with a lot of static on the line. And I get that. I don't know. I still haven't figured out what the problem is. If I knew, I'd fix it, but I'm still testing. It's intermittent. That's why I can't figure out yet. But one of these days, maybe I will. I've changed the plugs, everything. We'll see if any of that works. Okay. First thing, I'd like to notify everyone that, what is it, next Wednesday at 1900 hours Eastern Standard Time, Philadelphia time, Quebec time. Um, I'll be again on JFG's podcast. And for those, he's invited me to be there again. This is the third time. And I do appreciate his invitation. Just for those of you who don't know who JFG is, here he is. And this is the last time we had our discussion. Well, this is the first time we had our discussion. It's known as the public space. And you can see he's got that mean looking face in his YouTube site. It really scared me. I didn't know whether to go in there or not. But he turned out to be a pretty good guy. And I think he handled the both podcasts quite well. And anyways, if you are interested, next Wednesday, 1900 hours Philadelphia time. Okay. Now, for in my case, here I'm in Frankfurt. That's 1 o'clock in the morning. And last time we spent 3 hours debating with Peter, this mathematical physicist. And that means I stayed up all the way to 4 o'clock in the morning. Now, I'm used to these things, but just so you know, there's a time lag between, we're in first world, you're in second world over there in the United States and Canada. We receive time first. You are behind the times. You are time dilated behind us. So just be aware that over here it's quite late at night. Um, I've been wanting now since the beginning of December to discuss Mr. Sean Carroll. He's a very popular celebrity of mathematical physics. And I wanted to deal with his subject, especially the topic of fields. And something always keeps coming up. Something keeps interrupting or getting in the way. And today's no exception. Today I have another gentleman. His name is Jeff Yee. And I have no idea who he is, by the way. I just heard of his name for the first time this morning. Okay? So that's how much I know about him. I know absolutely nothing about him. Why do I get his name? Well, I'm in the mailing list of a society known as John Chapel Natural Philosophy Society. And this is a group of dissidents, or they consider themselves as dissidents. They consider themselves as opponents of mainstream physics, mainstream mathematical physics. And Mr. Yee is going to give, I guess, a presentation on this Saturday. And I always look them up whenever I get some mail of who's going to be talking for the Chapel Society. I go in there and find out, a little bit about them, see what they have to say. So I take the trouble to at least the 5 minutes worth. I do give them, okay? I grant them that much, and I do go in there and look at what they have, if they have a website, that's even better. And for sure, I can say that Mr. Yee impressed me as far as his website is concerned. Two things that impressed me about it, which I liked. Okay, that's what I'll be fair here. And what I liked, he was concise. He was to the point. He didn't spend a lot of verbiage like so many other people who just write reams of nonsense. And here's concise. It's to the point. This is what this is. This is what that is. I liked it. Second thing I liked it. It was illustrated. You don't find that. You don't find that at all with a lot of these people. They don't illustrate. And Mr. Yee has illustrated his website, and that makes it a lot easier to read. Okay. Okay. So those two are the things that I liked. What did I not like? Well, I did not like anything he said. What is it? The pictures were great. The superficial stuff was good. You know, the looks, all that stuff was good. The substantial part, the substance, no good whatsoever. And that's what I'd like to discuss today. And it has to do a lot with what Sean Carroll says, except that Sean Carroll uses a different word. He uses the word field. And Mr. Yee, he uses the word wave instead. And they think they're saying something different. When you look at, what they're really saying, they haven't said anything different. So this notion that people from the Electric Universe and from other dissident groups like the John Chapel Society, all these people think they're dissidents, that they're opponents of mainstream. They're all in the same boat as far as I'm concerned. They're all mathematicians. They do all their physics, quotations physics, all their physics with magic. And it's all irrational. Why is it irrational? It's irrational because they are in the business of moving concepts. Physics is first and foremost the study of objects. You can't do physics without an object. All these people do physics without objects. You'll never find an object in there. Electric universe, what do they use? They use plasma and electricity. Neither one is an object. It takes 2 years to convince them of that, but yeah, plasma and electricity are not physical objects. Okay? You say, what are they? Well, it's a long story. That's what it is. And quantum mechanics, general relativity, Mr. Yee included, he doesn't want to be associated with those two groups, but he's perfectly in line with them. There's no difference between him and quantum mechanics. There's no difference between him and general relativity. Absolutely none. Okay? The bottom line is they're not different. And they also use concept. What do they use? Well, they use waves. They use particles which ain't particles. Okay? And they use the same words. They use words like energy, force. Ooh, force. Mass. Some of them use mass. Force, mass. I didn't look all over this site, but I'm assuming somewhere uses the word time, maybe. Most dissidents don't like the word time or the word mass. They prefer to use things like waves, and stuff like that, ether. But they all speak the same language. They all talk about the same things. Okay, so let's get on with it. Jeff Yee, who is he? Or what is he about? Well, he tells you right on his first page, okay? And this is what caught my attention. He says the following. He says, now we have a new theory that explains things that were previously unanswered in science. Man, that's a load of stuff there that he said. He said something very, very profound. He's saying that he's got a new theory and it's going to change the world, essentially. And the question is whether his theory is new. Okay? I'm going to argue today that it's not. It has nothing new about it. Okay? And one thing you should be aware of is that Mr. Yee is a follower of other people who already came up with, I'd say, the same. He would probably refute this and say, oh no, my stuff is different. It's the same stuff as far as I'm concerned. It's the same stuff as Mr. G of Hazelhurst. I think that's his name. Let's see, I've got it here. I've met Mr. Hazelhurst. I had it right. Okay, Jeff Hazelhurst. We have two Jeffs today. And Mr. Hazelhurst, he's got a website, And you can see the first word there. We got a big problem with that. He says, on truth and reality. Mr. Hazelhurst talks about the truth. Okay, so that's pretty interesting right there and then. And what does Mr. Hazelhurst say? He's got also a buddy named Milo Wolf, which I think preceded him. And there were others. There was a Russian even before them. They came up with all this theory about what they call a spherical wave. And that's what they're going to use as their foundation. But I like how Mr. Hazelhurst puts in his website. By the way, I've known Mr. Hazelhurst for some years now. I've known what he's done out there. I've looked at his site, etc. He's got some pretty good quotes that you can, get out of there if you're interested. But he says the world is in much more trouble than any of us realize. He's telling me that. I'm saying we're about to become extinct. So I'm a little more direct on this. He's saying that we're in trouble, and I'm saying we're in more than trouble. We're going to die, and very soon. And we, humanity, are destroying nature on this planet. Well, we're in trouble, but not because we're destroying nature. We're in trouble because something totally different that's going to cause our extinction. And that's a long story, so I won't get into it. But it's funny that he mentions that we're destroying nature. That means he's a conservationist or a climatologist, probably. We're probably affecting the climate. I don't know if that's his case, but I'm almost sure that it is. He says but what does he say in terms of physics? He says we have made a very stupid error in considering matter to be made of tiny particles, when matter obviously interacts with all other matter in the universe. 120% in agreement. Totally in agreement, yes. There are no such thing as particles. And so in that sense, we're on the same boat. No problem there. But he says the following. He says, the spherical standing wave structure of matter in space explains this perfectly. That's what he uses to explain everything. And then he finishes off, he says, this true knowledge of physical reality, that matter is made of waves in space, is the cure for this ongoing insanity of humanity. Now, doesn't that sound nice? Okay, so Mr. Hazelhurst believes that once we all learn about the spherical wave, we're done. We can fix all the problems in the world. Whereas my version, as most of you know, is that extinction is unavoidable. There's nothing, absolutely nothing we can do to overcome extinction. Okay? So, and it's not going to be the environment. So, the environment has nothing to do with extinction. And the killing of the animals, the warming of the poles, whether it's happening or not, is irrelevant. Peak oil, irrelevant. All these are irrelevant. We're going to die because of economics, just like all other animals in the past. Everyone dies because of an economic collapse, the overturning of the ecological pyramid. That's my version, believe it or not. Up to you. That's discussed in other places, by the way. You can find me on the internet talking about it. Okay, so what is this spherical wave? What is Hazelhurst talking about? And by extrapolation, Mr. Yee, because he's in the same boat with these guys. Okay, and here we have a fellow who illustrates it on the internet. He illustrates the wave structure of matter. Here it is. Okay, looks something like that. Okay, sounds nice. And his name is Ray Tomes, and he's part of the same group of people, essentially. And he says in his YouTube video, he says, if you have two particles, they will make interference patterns. Two particles, they make interference patterns. Into what? I don't know, but that's what he says. A wave is made of the incoming path of a standing wave plus the outgoing path. We have an incoming path going, in other words, we have an incoming wave coming into a point, to a region, to a site, and there's another wave coming out. And these two waves, the one coming in, the one going out, they meet. And that's how you produce the standing wave. That's what this is all going to be about. These two components together make standing waves. Okay, that's how you make a standing wave. It appears to be standing in space, but it is actually composed of the inwards and outward waves. The waves are converging on a point and coming up from a point in opposite ways. These are real waves. Well, hopefully they're not like fake news, fake waves. Okay, hopefully they're real, but see, there's no such thing as a real wave, and that's going to be the issue here. What does Mr. Ray Tomes write? He says, matter is made of spherical standing waves. A standing wave is a wave that may be thought of as two waves traveling in opposite directions, and you can see that in the GIF there. For a particle, this means an incoming wave converging on the center and an outgoing wave coming out of the center, which is just the incoming wave after it travels through the center. Okay, so that's what all this is about. You see here how they illustrated that. They're saying that's a particle, I guess, right there at the center, and you have all these waves that are interfering with each other. Okay, some of them constructive interference, some destructive interference. Who knows what these people have in their minds? I try to visualize what they visualize. I can't see it yet. Anyways, so Jeff Yee, he illustrates it more or less in the same way. He says the in and out waves form standing waves about the central point. And that's the central point there. I guess one of those blips that you saw in the previous GIF there. The point-like particle effect at the wave center. So essentially he's explaining or describing the same thing. Okay, they're all on the same boat on this. Okay, so you've seen the wave, that's a spherical wave, and that wave is the particle. Particle is the effect of two waves. Okay, that's what you got to keep in mind. It's an effect that is produced by the meeting of waves. That's what they're trying to say here. Okay, what is one of the problems? Well, one of the problems that I had with the entire site were the words wave, for sure. I'm going to get into that in a minute, but there was a problem with the overall language. He uses the words energy, force. He used mass a couple times there, gave little importance to them. He talks about a particle. As you can see what a particle is, it's just a bunch of waves or interference of waves. And he does get into the photon. What is light? And that I am really interested in. So I had to see what he had in mind as far as what light is. Okay, let's go with the first one. What is energy? And I like the fact that he at least put the right question. He says, what is energy? And he doesn't define the word energy like nobody will. Nobody in mathematical physics will ever define the word energy, because the day they do, their religion goes down the drain. So, and Mr. Yee is no exception. He says everything around us is energy, whatever that is, right? Matter is energy, light is energy, heat is energy. In physics, energy is defined as the capacity. That's what energy is, the capacity, a concept, okay? That's what it is. And everybody pretty much, I mean, if you took high school physics, you heard the word energy, and if you look up in any book, it'll say the capacity. That's what it is, a concept. It is important to note that energy is neither created nor destroyed. Of course not. You can destroy your daughter's doll, throwing it in the garbage can or burning it or whatever, crashing it with rocks. But you can't destroy a concept. Have you ever tried to destroy love? And energy is a concept. So, hopefully you can't create it and hopefully you can't destroy it. And understanding energy at its fundamental level and why these laws of science exist may be the key to mankind's survival. Again, shows that he's in line with Mr. Hazelhurst, trying to look for survival of humanity when there's no chance whatsoever. Okay, extinction is guaranteed. Believe me, Mother Nature will not let us, escape it. Okay, so we don't have a definition of energy, so we got to look at a Nobel Prize winner, as we all know, Mr. Richard Feynman, and he says it is important to realize that in physics today, we have no knowledge of what energy is. Now, that comes from a Nobel Prize winner, probably outranks Mr. Jeff Yee. You look up in the Wikipedia, it says energy is defined as the capacity. No, that was another site that the one on the bottom is the one from the Wikipedia. Energy, the quantitative property transferred to an object. That's what you'll find in the wiki. And someone else defined it as, the capacity again. So we have the capacity, and we have that it's a property, and that this property is transferred. Now, we're not talking about land here. When you transfer land, you can say, yeah, I transferred my property. That's fine. But here we're not talking about that. Here we're talking about you transferring love, you transferring grace to someone else. Okay? You're transferring some concept. You're transferring information. And in that sense, no one's more of an expert than I am. I transferred information to the Cubans, to the Russians, to the Soviets, to China, to Iran. I transferred information, so I know what transfer information is. But that's the legal meaning of transfer. Okay, in the religion of the legal world, you can transfer energy. In physics, you can't. You can't transfer information, not in physics. In physics, you can only move objects. And energy and information don't qualify as objects. You can transfer paper like I did and ink like I did, but not information. No such thing in physics. Okay, so that's important. And if you don't believe me that I'm an expert, look me up on the Wikipedia and you'll find out that I am an expert in transferring information. Okay, so here we have energy illustrated. If nobody has defined the word energy, nobody knows what energy is, Mr. Yee included, then is there any way I can illustrate energy? Here you have Feynman, and he says, what is energy? We have no idea what energy is. And the problem there is the word what. Energy is not a what. You can't use the word what in the context of energy. In ordinary speech you can, but not in physics, because energy is not a what. A rock is a what. You can ask, what is a rock? A tree is a rock. What is a tree? What is a dog? What is a house? Those are whats. You can't say what is love, not in physics. And you can't say what is information, or what is energy, or what is mass. Because whats only have to do with objects. We only deal with objects in physics. And these people are using concepts as objects. They don't realize they're converting automatically, concepts into objects. And energy is no exception. And that's what Feynman's doing here. He's going in there and he's saying, what is energy? I have no idea. And so let's show Mr. Feynman what he missed all these years when he was in school. Okay? There's energy for you. I've illustrated it. Okay? That mysterious thing that you're staring at there, all those mysterious things there, that's energy. Okay, so get a good look at it so you know what we're talking about. That's energy, that weird thing that we've got there. Okay. Okay, so now that you've seen that, do I have a better idea what energy is? Of course I do. Here it is. This is energy, folks. Get ready. There it is. That's energy. Energy is another word for spirit. Okay, that's all energy is. Whenever you can't explain anything in religion, you say spirit or energy, whichever one of the words is just fine. People will understand, say, oh yeah, I understand. So there it is. That's what energy is. We don't use the word energy in physics. It's in religion where they use the word energy. Anyone using the word energy, religion. Okay. Same if you use the word force or the word time as physical objects like, warping time, warping space-time, carrying a force, moving a mass, all religion, nothing to do with science. Okay, here we have Jeff Yee says, this site, this is in his site, right? This site is dedicated to a new theory on energy. Okay, he failed there already because we don't know what energy is. He doesn't know. He hasn't defined it. titled Energy Wave Theory, EWT. That's what he's going to put out there. He's going to say energy is part of his energy is part of his wave theory. Okay, so it's an important part if you put it in the title. That requires a fresh new look on physics. Well, it doesn't look like a fresh new look. It looks like the old. Shamu, hi, how are you doing? He says, muhaha, no escape. Yeah. Anyways, here we have Mr. Yee, and he says energy wave theory. Okay, Jesus, it's a very important name, a very shocking name. He says that requires a fresh new look at physics, and I'm saying, well, there's nothing fresh about this look. It looks like the old stuff, the same old, same old. And he says energy is the motion of the universe, ether, right? He puts it in parentheses, which travels as waves. So again, we have energy which travels. Now that is scary. When a concept starts moving, oh man, it's because you drank too much beer. That's what it is. And he gives us an analogy. He says, analogy is a pool of water. Imagine that the pool is flat and stationary. Usually my pools are have depth. I don't dive into a flat pool, but we'll skip that. That's pushing it a little too much and would take a long time. But it's important because I use that argument against the flat earthers. Flat earthers say the earth is flat, and I'm saying, well, how flat is flat? And, flat is a word that belongs to geometry, not to the physical world. Flat belongs exclusively, there's nothing flat in the entire universe. Everything has some kind of depth or thickness, okay? So that's why the word flat here shows that he's not careful about his language, but I'll continue. There is no movement of water in any direction within the pool. There is no energy in the pool. There had better not be, because energy is not a physical object. You can say there's a boy in the pool or a beautiful girl, maybe, a swimsuit lying around or something, or a bottle fell into the pool, but you can't say energy is in the pool. Energy is a concept. It can't be in the pool. There better not be any energy in there. Zero energy, hopefully. Next, imagine that something violently shakes the pool. Okay, so we have an earthquake. Waves begin to thrash around the pool in all directions. Now the pool has energy. Oh, does it? Why? He says it has the ability to move objects, such as a toy on the surface. I thought it was the water that moved the toy on the surface, not energy. Hopefully it was water and not this concept, mathematical concept that has nothing to do with physics or with a physical world. In the pool example, energy is the movement. There he confirms. Energy is movement. That's what he's saying. He's not talking about the water. He's talking about its movement. He's talking about waves again. And he's saying energy is movement. Okay? So there's his definition hidden in there, right? He says, which flows as waves. Okay? So now we get a relationship between energy and waves and movement. Okay? In the universe, it is the movement of the ether. So we got an ether theory. And by the way, all these people talk about the ether, and the ether has never died. Even after, what is it? Forgot their names. Old age. Morley and Michelson and Morley. Michelson and Morley, what is it, 1887? They came up with this notion that there is no ether. Okay, they try to measure out there light going in different directions to see if the ether wind would blow in one direction or the other. So there's no ether. But then everybody says, well, what is light waving in? What is the light the waving of? What physical entity is waving? And so they couldn't drop the ether. They couldn't drop the ether. Even Einstein, if you look at his address, what was it, 1920 in, Leiden, Germany? And he says, general relativity, space-time, right, cannot live without the ether. Space-time is an ether. As Nobel Prize, can't remember his name, said, space-time is ether, except that it's taboo to say that. You can't say that in mathematical physics. You can't use the word ether. It's forbidden, okay, period. You can't use the word ether. Ether died. 19th century, that's ether. Today they call it space-time. So they just change the names. Quantum mechanics, they call it either the direct C or they'll call it the false vacuum. They've got all these euphemisms for it. Everybody believes that there is a medium filling space, or that space is in fact the same as the ether, as the medium, as the space-time. Okay, so one or the other. Either space is a can that holds ether, holds space-time, holds vacuum or false vacuum or whatever you want to call it, or space itself is equal to it. And they've never decided which. Okay, they never figure out if space is something different. Okay, Martin, I'll skip your comment there. Okay, so we have this ether. It's an ether theory, okay? That's what he's going to be using. He's going to say, essentially, that wave is the shaking of the ether. And I think most of you already are much aware of that. Okay, so what's the next word that he analyzes that I liked in his website? The word force, obviously, you know. Where does he get this? Well, he gets this from quantum mechanics, obviously. He gets all this... what is it? All this words, all this jargon from these folks. And Martin, I had to approve your comment, I guess, because you had this strange word in there which the system didn't recognize. Anyways, what is a force? Well, he says energy wave theory begins with simple assumptions that matter and light are based on waves, but they have different wave types known as longitudinal and transverse waves. Forces like electromagnetism, gravity, and the nuclear force that holds atoms together are unified into one force with a difference in wave type and amplitude, okay? And there at the bottom he says forces. Instead of four distinct forces, there is one reason for a change in motion of a particle: to minimize amplitude. Keep that in mind, to minimize amplitude. That's going to be important in his theory. Forces have been united in this theory. In other words, Mr. Yee is proposing that there is a single force in the universe. Okay, keep that in mind. What are the forces? We have gravity, we have electromagnetism, according to the religion of quantum mechanics. We also have the gluon, which gives us the strong force, and we have the weak force, which is carried by the Z's. Okay, they've invented all these forces. The gluons are essentially the forces that keep the strong force keeps the quarks together inside, the atom. And the weak force is what the atom expels spontaneously sometimes. Okay, so we ask, what is a force? I think that's a valid question. You want to know what a force is. Okay, so let's start there. And this is what Mr. Yee says. He says, there are natural forces all around us that push and pull or pull objects. Notice that. I just want to stay there for a second. Forces that push and pull objects. He mentioned only two forces, and then suddenly at the bottom he illustrates four of them. Now that's kind of weird, because if you only mention push and pull, which are the only two forces any rational human can imagine, the only two forms of contact that we can imagine, you either push on something or you pull, then what are all these four forces that they're talking about? Maybe they're talking about the four horses, like the four horses of the apocalypse. Is that what they're talking about? I mean, what is a strong force and weak force and electromagnetic and gravitational force? There's only push and pull, period. So whatever, I mean, the strong force is a pull force. It's a tug force. It keeps the quarks together. So it's a pull force, just like gravity. And electromagnetic force, electromagnetism, is a push. It goes outwards from the atom, just like the weak force, which is where it expels, apparently some matter from the atom, okay, called radioactive decay. Okay, and he says a force is any influence. So now we know what a force is. It's just an influence, okay? And so it's a concept again. You can't say a force is a solid like a rock. You can't equate the word force with rock. Okay? So that's essentially what we're criticizing here, the language that he's using. That's important to note because, the only way we can understand what he's talking about is, if he tells us what these words mean. And he says force is defined as an influence. Okay, everyone recognizes gravity because we all feel the effect. Okay, great. Electromagnetism is another common force split in two components, etc., etc. Okay, we'll skip a lot of this stuff. Essentially, the problem here is that he mentions the four forces of quantum mechanics. That means he is a quantum mechanic. Okay, he's no different than them. He's just going to have some little minor adjustments to quantum mechanics. But he is a guy who receives all his information, all his wording, all his jargon, all his ideas, all his atoms from quantum mechanics. And look at the atom that he drew there, just the electromagnetic force binds atoms. What atom did he draw? The planetary atom, which is what everybody in quantum deals with. They deny it, but then that's the one they use. Look up the word atom. For example, if you look up the word atom in Google, just Google it, images, what you'll see is the planetary model just everywhere, absolutely everywhere. And you say, well, hold it, is that the real atom? And any quantum mathematician will tell you, no, that's not the real atom. If you really, really want to know what an atom looks like, well, you got to go to college. You got to go to get a PhD at the university in mathematical physics. Then you'll know what an atom looks like. And that's weird because, if someone asks you, what is a dog? You just point to them and say, that's a dog. That's how simple it is. And these people can't point to their atom. They can't say, this is an atom. They can't do that. And they'll never be able to do that because the day they do that, their religion is done. They can't illustrate a single object used in quantum mechanics, all of mathematical physics. And Mr. Yee is the same. He illustrates, but what he's illustrating is nonsense. It's just waves. And there is no such thing as a wave. We'll get into that in a minute. Okay, and so what causes a force? Here it is. Drum roll, And he says, in energy wave theory, his theory, right? Particles seek to minimize amplitude. Okay, so if you lower the amplitude, that at some point it becomes a particle. And you can see he begins with a big amplitude wave. When it shrinks to a low amplitude, it's a particle. And then on the other hand, between the two particles, you see another wave, which is some intermediate value between the long one that came in and the particle itself. And that's the disturbance that one particle sends to another. That's his general idea. That's the one he's trying to propose here. And he says there's one fundamental energy wave right there at the bottom, okay? But it will change in wave forms when it reflects off a particle core, in waves and out waves, again, coming in and coming out, okay, combined to create a standing wave. So you have a wave coming in, which is not the same as the wave coming out. Together they form a standing wave. I have no idea how, okay, but that's what he says. And that's how, the wave in the ether propagates, and that's how these waves create particles, and that's how they influence each other through this waving of the ether. So all we have in the universe is just this ether, whatever ether is, and different degrees of vibrations determine first if it's going to be a particle, if a certain region is going to be a particle, if it's just going to be a disturbance that affects something else, okay? And I guess with this they also produce gravity and light and the whole works. Okay. Beyond the particle's radius, it transitions back to a traveling longitudinal wave. I'll talk about that in a second. When it causes a particle to spin, a transverse wave is created. Okay, so if this particle, which is a wave, if it also spins, then it creates a transverse wave going outwards. Okay, so they have all this done with waves. And if you want to know what causes a force, well, he says particles will always move to minimize its displacement, wave amplitude. He says all these amplitudes is what's going to govern whether something is simply a disturbance or a particle. At least that's what I understand from it. Irrelevant anyways, because as I will say next, there is no such thing as a wave. Okay, and people should watch my video. What is it? Wave Theory for Idiots. That's the title of it. And I think it's a proper title, really. So that they don't use the word wave ever again. Okay, at least to make their case. They can use the word wave like I use it to, depending on the context, but not to make my case with it, saying, there are waves out there. No, wave is a concept. It's a dynamic concept. There's no such physical standalone object called a wave, which is what Yee is treating it as. Okay, so what are waves? And here we have it. He says, got to put this up there as well, so you can have the illustration. Okay, he says, there are 5 laws that describe the behavior of matter and forces in the universe. And I only put 4 of them there. The 5th one was, in my opinion, not relevant, so I didn't put it in there. Anyways, energy waves travel throughout the ether. He talks about waves traveling. I thought wave was already a traveling thing. So we have a traveling traveler. Okay, through the ether. Okay, so energy moves through the ether. Okay, ether, granules. I like that word granules because now he chops up the ether into little particles. And you wonder what gives shape to each one of those particles. What encapsulates each particle? Space. And then he would have to explain what space is, obviously, right? Where does space end? And do the granules continue on to a parallel universe or get swallowed by a black hole or whatever he's got in his mind? Ether granules, what the hell is a granule? Again, these people see space as a medium, and they see space as something physical, and they get that from quantum mechanics, which says that they could pop particles from the void. Positive and negative particles which combine to form space. Space can also break them up into 2 opposite, polarity particles. Okay, so he says ether granules are the medium that can respond to a wave such that it can transfer its inertia. So we're transferring inertia now. And momentum. We're transferring all kinds of concepts here to the next granule. We wonder, and the granule is also a concept, by the way, because there's no physical object that they're referring to when they talk about a granule. The granule is just another word for particle. And what was a particle? Well, a particle is a vibration of a wave, which is, and a wave is a vibration of who knows what, it says in the direction of motion. So we're transferring inertia and momentum in the direction of motion. How that gets transferred is another question, because if each granule is a discrete granule, you wonder how one granule affects the one on the other side of the space that's separated from space from the next particle. Okay, and the other issue is if the wave is made of particles, what makes the particle go up and down? You would think that if we follow Newton, particles should all go straight or rectilinearly. They should move rectilinearly. And the only reason they would go up and down is if they're tied together, if there's something connecting the particles. But if each particle is a discrete particle, why would they jump up and down in an oscillating manner or in an undulating manner, wavy manner? But I like that one. It may have a memory to understand its state. Oh, I love that one. It takes a lot of beer to understand that one. So particles now have memories to understand their state. Great. Ether wave centers reflect longitudinal waves and may assemble information to create particles via constructive and destructive wave interference. Ether wave centers move to minimize the wave centers, right? The centers are the ones that move to minimize amplitude on the wave, thereby preferring the node position of the standing wave. Okay. And again, you can see it there. That's essentially your wave, similar to what I showed you earlier. Okay, this is what these people have in their minds. Okay, so what does hyperphysics and the Wikipedia say about waves? What are waves? Well, here you have it. Okay. If you never knew what a wave is, here it is. Wikipedia says a wave is a disturbance that transfers energy, whatever energy is. We never figure that out, but it transfers that thingy. And what does the hyperphysics site say? Well, elasticity is a source of energy, and a source of energy are the preconditions for periodic motion. That's essentially what a wave is going to be, periodic motion. Okay? And they give an example. A pond has an equilibrium level and gravity serves as a restoring force. This is again hyperphysics, not Mr. Yee. When work is done on the surface to disturb its level, a transverse wave is produced. Okay? On the other hand, if you want to know what a longitudinal wave is, a disturbance of the air pressure at a single point produces a spherical traveling pressure wave sound. A sound wave in air is a longitudinal wave. Okay, so now we're getting to the bottom of things. We've got an example from the pond for a transverse wave, which is not totally true because, the water waves that Huygens analyzed in the 16th century, they have both component. They have a transverse component and a longitudinal component, but that's beside the point. And then we have longitudinal waves, sound. They just go back and forth and bang on your ear. That's why you can hear. Okay, so what's next? Well, we have a wave definition from Mr. Yee. And it's important to put these two things in there first. His notion or what a longitudinal wave is, and here we have also what a transverse wave is. And he says the following. He says, understanding waves. Well, hopefully, let's see if we can understand what a wave is. Energy is the motion of the ether. Okay, so we can't get away from an ether. We don't know what an ether is. A bunch of particles, obviously. Waves may change forms, okay, and be additive or subtractive when in the presence of other waves. But the energy will always be conserved, okay? I guess they have a little glass and they conserve it in there. Whatever concept energy is, whatever energy means to them, okay? Photons are transverse traveling waves. I like that one. I won't go over the other ones because I really wanted to get to the bottom of what photons are in his theory. And just like everybody else, he says photons are transverse traveling waves. He's got examples there. Transfer is a wave vibrating at right angles to the direction of its propagation. That's what they say light is. And traveling regarding the motion, a wave in which the medium moves in the direction of propagation. Okay, so now you know what a longitudinal wave is and what a transverse wave is. We're interested in the transverse wave because the transverse wave is what they claim light is. Okay, and we've heard of that all the way since the days of James Maxwell. What Mr. Yee never heard of is that there's a third kind of wave. He knows about what are known as one-dimensional longitudinal waves. He's heard about two-dimensional transverse waves, and that's the extent of his understanding of waves. He never heard of a torsion wave. Never heard of that. In fact, no one in mathematical physics heard of a torsion wave. Otherwise, they would have discovered the nature of light. And so here, let's educate them a little bit. Here we have a one-way wave, which is a transverse wave, and also the longitudinal wave is a one-way wave. Torsion wave is two-way, goes both directions simultaneously. Whenever a rope torques, you have at both ends. At one end you have counterclockwise, and the other end you have clockwise. So obviously the rope, the torsion wave, whatever you want to call that, that torque, is moving in both directions simultaneously. More importantly, a torsion wave is extremely fast. In fact, there's no object that we have ever invented on the face of the earth, no rocket, no airplane, no steamboat, no car, nothing that we have invented that goes as fast as a torsion wave. Torsion wave is the fastest thing you can imagine, okay? And, here you have an example of that. Here's your transverse wave, and you can see that first the rope must be tied at the other end. Second, it doesn't go straight or rectilinear, the waves. Is it fast? No. As you can see, showed you a minute ago, it's not fast at all. And what? It doesn't require a medium? What is that where you're staring at? That's a rope. The only way you can create a standing wave with something in your hand, and you got to tie it at the other end. And so all these people want to say that's how they simulate the standing wave with something in their hands shaking. But when they talk about light, says, well, it's got no medium. It's the waving of the wave, whatever wave is, of the ether. What's the ether? Particles. What are particles? Waving of the waves. And so you got a circular reasoning there all the time. You can't avoid it in quantum mechanics, or anyone who stands up for or proposes any theory coming from quantum mechanics. And what they should have noticed is that you can't use the transverse wave at all. And why? Because longitudinal waves are faster than transverse waves. Longitudinal seismic waves reach you 1.7 times faster than transverse waves during earthquakes. So when you have an earthquake, the longitudinal wave reaches you faster than the transverse waves. And this is a known fact. In fact, what you should be aware of is that if this is true, when there's thunder, lightning, you should hear the thunder before you see the light, if light is a transverse wave. Okay? We have a naughty boy, Martin, here, says something, their hands shaking, naughty physics. Yep. Okay, but this is the issue. The issue is that if light is a transverse wave and sound, we know for sure, is a longitudinal wave, when there is thunder, we should hear the thunder before we see it. And I'm not talking about a blind man here. I'm talking about simultaneously. You look at the thunder, you should hear it before you see it in the sky. If light is a transverse wave, because transverse waves travel slower than longitudinal waves. 1.7 times faster are longitudinal waves than transverse waves. And there's a reason for that. This wave has to go up and down. The other guy goes straight. There should be no reason for this guy going up and down, going faster than the one that goes straight ahead. And torsion waves leaves both of them, in the dust. So, the torsion wave really is a much better candidate. Okay. The other thing that transverse waves cannot explain at all, okay, is this relation. It comes from James Maxwell's calculations, and that's the velocity of light is a constant. The way you calculate it, it's 300,000 kilometers per second, and the only way you can change that is by either raising the frequency and lowering the wavelength, or vice versa. Okay, so the only way you can explain this is with a rope. Okay, again, this is an equation of a rope. If you torque a rope, and here let me just do the experiment for you, you're going to get more links. Here's my famous rope. I'm going to give it to a museum. Here's I torqued the rope quite a bit. Okay, how many links do we have between my fingers? Okay, we have 1, 2, 3, 4. 4 links, I guess, there. Okay, if I torque it more, well, I'll untorque it, which is easier now. Okay, how many links do I have now? Well, I only have 2 links. Okay, only 2 links, and each link is longer. The wavelength is longer, and we have less frequency. Okay, what if we want to have more frequency? Okay, let's torque the rope. Okay, now we torque it. Now again, we have more frequency. We have 4 links, and each link is shorter. C equals frequency times wavelength. Again, the equation of a rope, they never figured it out. Okay, so we got that. Can a wave, Mr. Yee's wave, can it produce pull, the force of pull? I mean, we're talking about 2 forces in the universe, just push and pull. No problem if the wave comes out of the atom and pushes. We can all understand that. Let's see if it can pull as well. Let's see if I can get this back. I lost it. Where did it go? Oh, here it is. Here's two electromagnetic transverse waves at the bottom and also mimicked by water at the top. Do you see any pull? I mean, we can all understand push, right? Can you pull with this mechanism? Because what Mr. Yee is saying that we have one wave coming out of the particle, another one going in. That's what's going to create the particle. It's going to make the particle, right? It's going to make it what he calls the particle effect. There's no real particle. It's just an effect. Okay, so that's what we're made of. You know, all these particles in our body, we're just effects of these waves, right? Okay, assuming that's all true, can a wave pull on something if it's an outgoing mechanism? I mean, if you throw particles at something, can you attract it? And if you throw a one-way wave at it, can you attract it? You know, how do you pull with this? And you can see there are waves smashing against each other. There's no pull whatsoever. It's only push. So you can't pull with waves. And what else do I have here? Here we have, just in case I took trouble getting Mr. Dr. Quantum so that I have some whatchamacallit, have Dr. Quantum, you know, so that I have, what is he called? Little bit of authority behind what I'm saying here. And here you have his waves coming out. Do you see any pull? I mean, all I see is push there, okay? So no pull whatsoever. You can't pull with waves. With any one-way mechanism, you can't outward one-way mechanism, you cannot produce pull. And that's the big problem that quantum has had all these years, mathematical physics in general, okay? None of them can produce pull. Okay, so what do we end up with here? He says he wants to tell you what a particle is. And he says the following, Mr. Yee, right? He says the energy wave theory. Particles are standing waves of energy. So we have standing waves of who knows what. Standing waves can only be produced if they're tied at the other end. They're very slow. They're only outward going. But he's going to make particles with this, and he's going to explain all the phenomena in the universe with these standing waves. What are these waves of? Of energy, an undefined concept. Okay, so that's the status of, that's the state of his theory. And so he tries to illustrate what he's got in his mind, what it is. He says, you have an in wave, a longitudinal wave. You have a standing wave in between, okay? And then the outgoing wave is another longitudinal wave. So all he's got is waves. Waves made of more waves, and particles which are made of waves, and everything is just waves. Okay, so there's nothing there. There's nothing to sink your teeth in his entire theory. It has nothing to do with physics. Okay, but he says he's going to solve all the problems in the world with this. So I wouldn't hold my breath if I were you. Okay, and he goes into what is a photon. Okay, and he says a photon is the carrier. He carries. Okay, of the electromagnetic force. So a photon carries a force. I wonder how you do that. Do you put it on a knapsack, behind your back and carry the force? And is the quantum form of all electromagnetic radiation. Where did he get all this? From quantum, obviously. He takes that as gospel. He hasn't ever criticized or attacked quantum mechanics. He's never questioned it. How can you question so much authority? I mean, that's what he learned in college, right? How are you going to question so much authority? So many celebrities, people like Niels Bohr and Dirac and Born and so many others. I mean, you can't question all that knowledge anymore. And so photon creation. How does he create a photon? He says energy wave theory. A photon is caused by particle vibration. So look at this particle vibration. The question again is, what pushes the particle up and what pushes the particle down? Why does it go up? You would think that, like, he's got it there illustrated, they're all connected. Then yes. I mean, if a rope or a string or a wire connects all these particles, then we can understand why if you shake one up, the next one's going to follow through, and then when you shake it down, the next one, the neighbor behind it, is also going to come down. We can all understand that. But if these are all discrete particles, that brown line that he's got in there, or orange line, whatever, is quite misleading, because he's suggesting there, or he's insinuating that they're all connected when they're not. These are all discrete particles, and now he will not be able to explain why the particle goes up and then goes down. Newton's law forbids that. But they do it anyways. They just say it, and they say, that's how we create standing waves. Again, standing wave, you do it with a rope, elongated mechanism. All the atoms are connected, all the molecules are connected, and they're held at both ends. They have to be held at both ends. And they don't travel straight, so it doesn't matter anyways. Okay, so energy wave theory of photon is caused by particle vibrations. And he says particles were described as waves of energy. Okay, again, what is he talking about? We don't know. Creating standing waves from in waves and out waves. He's got an incoming wave, an outgoing wave. Somehow with that, he thinks he creates a standing wave. Whatever it is. Longitudinal waves, well, he says the out waves, they're longitudinal waves. And this creates a secondary transverse wave. Okay, so it's all waves of waves, and we never see what physical object is there for us to sink our teeth in. Okay, and he gives an example there of how all this fits in his mind. He says, imagine a balloon underwater in the middle of a pool. Balloon I can understand because it's a physical object, which is rapidly inflated and deflated repeatedly. The balloon will send spherical longitudinal waves throughout the pool, okay? Now imagine the balloon, while still being rapidly inflated and deflated, is also traveling up and down from the bottom of the pool to the top and back again. This will create a secondary transverse wave perpendicular to the motion towards the sides of the pool. Okay, so he says that there is something going up and down. The question is, what pushes the balloon down and what pushes the balloon up? That's all he's got to answer. See, hopefully the balloon didn't go down by itself. And that's what's wrong with his theory. He misses the big points. The big points are, what pushes the balloon down, not whether the balloon causes the wave to be created and move to the sides of the pool. Of course it does. Once you move the balloon, it does. The question is, why does the balloon go down? Why does the balloon go up? What's pushing it down? What's pushing it up? How does he do that magic? Does he do it with his hands, or does he do it with spirits like energy? And so again, here we have major problems with this kind of thinking. These are the wave theorists, and they're trying to push their agendas. The spherical waves, that's what these people believe in. That's what they propagate. That's what they disperse out there. And they claim to do things differently than the mathematical physicists of the mainstream, when they're exactly the same. There's no difference. Why? Because they use the same language. They use the same words: energy, mass, force, time, maybe, charge. They talk about particles. They can't avoid the particle. They have the same atom, the electron bead going around the atom or standing next to it or whatever. So they accept all that. They take all that for granted. They never question any of that. They say that's a done deal. We've proven that, so now we're just going to work with it. And that's the problem they're having here. And people like Yee come out of college, if you get a degree in college today, it's because you had to pass all the exams that your teachers put in there for you, your instructors. And that means you're going to have to parrot. You're just going to have to learn by rote. You're going to have to regurgitate what's in the books and what the teacher said in class, and you're going to have to put that on the test. Otherwise, you don't get your degree. So the worst place to get an education today is in college. Education. If you want a job, that's a different story. You go to college, you suck up, and you get to know people, and you will get a job. You get your connections. You belong to some kind of sorority or brotherhood. Fine. Then you'll get a job. You know people. I'm talking about education. I'm talking about understanding and really trying to figure out how this universe works. You're not going to get it if you come out with what they taught you in college. It's very few people, extremely few, counted with, I think, less than the fingers I have in one hand. People like Mr. Stephen Crothers, who can't get a PhD because he can't find an advisor. And I said, well, I think he's lucky, really, because if he got an advisor, he's in trouble. It means he found someone in the world who made it to the top, who's got a PhD, and who doesn't believe in quantum or general relativity. I'm not sure you're going to find someone like that. So in a way, it's good news that he can't find an advisor. Okay, anyways, that's what I have to say about Yee, and you can go to his website. I put it there on the Rational Scientific Method in Facebook, so you can read up. Again, what's good about his site is he's very concise. I like that. He's got drawings. I like that too. But all of what he says is nonsense. And by the way, I'm going to put a link to this video for him. I don't want to blindside him. I want him, he can beat me up if he wants to. And the only other thing I'm just going to add today is that next Wednesday I'm going to be on JFG's program. I'm going to be talking about the rope model. And again, there's only 3 possible models. We've had 2 for the last 400 years, wave and particles. We're introducing the rope model. We're saying all particles, all atoms in the universe are interconnected, physically interconnected. Light is a torsion of a rope. That's what's moving back and forth. That's light. And that also explains action at a distance, gravity. Acceleration of gravity has to do with the fact that everything's interconnected. And the issue there is that I'm going to be presenting the rope model next Wednesday. And I'm gonna, and there's gonna be, and I'm telling you this up front so that you don't waste your time. You either watch it because you're interested in watching, or you say, well, Bill, I've heard all that before, so I'm not gonna even listen to you. That's fine. I don't get offended. I'm gonna show light. I'm gonna show gravity. I'm gonna show magnetism and electricity. Those 4 things. And I'm gonna be as concise as possible. Okay. I'm gonna show these 4 magnets, and I'm gonna say there's gonna be 2 conclusions. One's gonna be a strong conclusion. The other one's going to be a weak conclusion. Strong conclusion: quantum mechanics, general relativity, mathematical physics, electric universe. What is it? This society, Chapel Society, all nonsense, all magic, all spirituality, nothing to do with physics. And a rope can explain everything, while these cannot. The weak conclusion is, as a minimum, okay, the rope should be considered side by side with a wave and with a particle. See you on Wednesday. Hopefully someone will visit me at the nice chat that we're going to have there. We'll see you then. Bye-bye.